Welcome everyone, and welcome to the AluVET Vocational Training and Education for the Aluminium Sector. This training is co-funded by the Erasmus Programme of the European Union. I am Jan Lukaszewski, the Technical Manager of the Aluminium Federation in the United Kingdom. The Introduction to Metals series of modules explains the simple theory of metals and of metallurgy to enable students in subsequent modules to understand aluminium, its alloys, aluminium heat treated, and how aluminium is rolled, extruded, and/or welded. And this module is Introduction to Metals Tensile Testing. This project is funded with the support of the European Union. This publication reflects only the views of myself and the Aluminium Federation, and the Commission cannot be held responsible for the use which may be made of the information contained therein. This module, Tensile Testing, follows the previous module on plastic and elastic behavior of metals. And this module describes the tensile testing equipment and the process of tensile testing, and it explains the measuring units used to quantify the yield and tensile strength and the elongation of a metal. This module will explain how to carry out a tensile test. This will enable you to measure and calculate stress and strain, understand the units of stress and strain and how to calculate them, and it will allow you to quantify elastic behavior, determine yield stress, plastic behavior, ultimate elongation, and the maximum tensile strength. The correct application of these engineering units will enable the correct design of products. Understanding the engineering units will enable you to measure and establish the quality of a metal. In the tensile test, a sample, it could be a test piece or an actual component, is subjected to controlled tension, a controlled stress until it fails, a controlled load until it fails. The basic tensile testing machine consists of a frame that supports two cross beams, one fixed and the second movable. Normally, the bottom cross beam is fixed, indicated by the red arrow, and the top cross beam can be moved upwards and downwards. Attached to both cross beams are grips. In this picture, the large black vices. The grips hold onto the test piece so they can take the tensile component. They can be designed to take a component, or they can be designed to take a test piece. And the vices clamp the test piece being tensile tested. A force is then applied to the moving beam, moving the beams apart, so stretching or straining the test piece. The force can be applied mechanically, that is a dead weight, or hydraulically, or through a motor and screw arrangement. The movement of the movable cross beam is measured electronically. So the machine applies a force to the test piece by moving the top cross beam upwards out of the way. So it is applying a load to the test piece by moving the cross beam. And the force is applied through the clamps into the test piece, loading or stressing it. So in the test piece, in the tensile test machine, we clamp a test piece, and by moving one of the cross beams, we stress or load the test piece. Now, the force applied to the test piece by moving the cross beams is measured using a load cell electronically and is plotted against the movement of the movable cross beam. So we measure stress, the force that we apply for moving the cross beams, against the stretch or the elongation of the test piece. This measurement of applied force gives us a measure of the load. In the tensile test, the sample is subjected to controlled tension through the loaded beams until it fails. The applied force is measured electronically and plotted against the movement of the movable cross beams. The measurement of applied force gives us measures of load or stress. The measurement of the crossbeam gives us measurement of elongation. So if you go back to the previous module, we plot stress vertically, which is the force applied to the test piece, and we plot horizontally the movement of the test piece or the elongation. Now, up to the yield point, the yield stress, the elastic movements are small, so are measured electronically using an extensometer. And you can see the extensometer, the green device, clamped onto the test piece. Once the metal has yielded, the extensometer is removed and we measure plastic deformation, that is the stretch of the test piece from movement of the cross beams. Thus, we can construct a graph of stress against strain. Stress is the vertical axis, the force that we apply. Strain is the elongation. I have a little video now of a tensile test. The video plots the progress of a tensile test. Initially, we measure elastic linear movement of the load against stretch. Then we shall see the yield point and the transition from elastic to plastic behavior. And finally, we will observe the maximum breaking load, maximum breaking stress. The units are in inches because this is an American video. The device on the right-hand side is actually the extensometer. The test piece is right in the middle of the picture. Now, initially, we're only seeing elastic movement. And now we're seeing plastic, it is yield and it is necking down. Remember, the planes of atoms pull apart. and we have final failure. And look at the neck down sample. Now we can measure elongation on the right hand side, the stretch, permanent elongation. And here we have the complete graph. So up to the yield strength, it is linear elastic movement. Above the yield stress, we see plastic deformation up to the maximum breaking load. And then we see ultimate elongation after that.